Let's start 17.3. And page 7 is our note. So we're just going to review similarity and give you some rules for why triangles are similar. Okay, the first rule for similarity, note this is not congruence. This is not why triangles are congruent. Okay, this is why triangles are similar. Okay, so first of all, you have angle. So if two angles, note in triangles that are similar, the angles are congruent. Now, so to show that two triangles are to show that two triangles are similar, you have to have a minimum of two angles congruent to each other. Okay, two angles in one triangle congruent to the corresponding two angles in another triangle. So then we call that rule angle. If two corresponding angles are congruent, then the triangles are similar. Okay? Now, down here at the bottom, it says determine if the example below are similar by angle similarity. If yes, write a similarity statement. So the first triangle says we have, let's see, 75, 74, and the other triangle has 75 and 31. Well, let's find the third angle by taking 180 and subtracting that. So all three angles together add it to be 180. So if we take 180 minus 74 and then minus 75, then we're going to end up with, that will be 31 degrees. 180 minus 74 minus 75 is going to give you 31. And so then on the other one, you do the same thing, or realize that it's going to be 74. So 180 minus 75 minus 31 is going to be, they'll put it in there like this, 74 degrees. All right, so it looks to me like the angle, there's two angles. So you can say angle E is 74, angle B is 74, angle A is 75, angle D is 75. So you have two angles that are the same. So that means they are, yes, similar by angle similarity. Okay? And then the statement you could say is triangle ABC is similar to triangle. So if we said ABC, we would have to say DEF to make them match up. Okay? Example 2. What do we know? I've got an angle here, angle V and angle Y. Do I have any other angles? Yes, I have vertical angles here. Okay, so I have two angles. So yes, the triangles are similar. So yes, by angle similarity. And let's write the statement. Let's say, we'll start with the triangle, the bigger one here. It didn't specify which way we had to write the similarity statement, so we'll just do it how we want. So I'm going to say, well, all right, VXW, so triangle VXW is similar to triangle. So if I want VXW, I'm going to have to go YXZ. Okay. Side similarity. Now, this is referring to the sides. Now, the sides have to be proportional. Okay, so you have to match up all the sides, set them up as fractions, and make sure that that ratio, okay, or that fraction, equals in all three cases. So side similarity. If all corresponding sides are proportional, then the triangles are similar. So before you can say the triangles are similar, you first have to say or show that all the sides set up as fractions with the other sides of the other triangle, and that those fractions are all the same. They all reduce to the same amount. All right, so you'll see what I mean down here. Example 3. So, what if that will help at all? Okay. So example 3. Let's match up corresponding sides. So if, looks to me like the smallest, second smallest, and largest should match up with the smallest, second largest, and largest. Okay? So if I match up those 3 to 6, let's just write it like this, 3 over 6, does that equal 4 over 8? And does that equal 5 over 10? Do those all reduce to the same thing? 1/2, 1/2, 1/2, yes. Those all equal 1/2. And you could also do the perimeters. 5 plus 4 is 9, plus 3 is 12, over 10 plus 8 is 18, plus 6 is 24. That also reduces to 1/2, so that all should be true, okay? When you're doing side similarity, you're just doing the sides, but I'm just pointing out also that the perimeters are equal, or the ratios would have the same scale factor. Okay, so this is yes, side similarity, and let's write down a statement. We'll say triangle, let's go QPR would be similar to triangle. If I went QPR, then I have to go TSU. And those two are similar because of side similarity. All right, let's go to example 4. So how do we match up the sides? Well, you just have to, since you have all three, let's look at the value. So 24 would be the smallest. What's the smallest on this one? 30. So let's match up. We'll just go left to right here. 30 over 24. Does that equal? Let's see, next up from 30 is 32. So next up from 24 is 25. So 32 would have to match with 25. And then 35 would have to match with 28. So reduce all those fractions, okay? So if you're, or you could just divide them in your calculator and look at the decimal answer and just see if they're all the same. But let's see, 30 over 24, that's 5 over 4. 6 divides into both of those. And 32 over 25. Let's see, that's 32 over 25, and 35 over 28, I don't know that that reduces either, so you can divide all those if you want, and you'll realize that some of them divide and you get 1.25, and other divide and get 1.28 if you want to divide them and see, but these are not similar. Those do not equal. Those fractions do not all equal each other. Okay, side angle side similarity. So this is the third rule that we can use to show that two triangles are similar, is if you have two sides that are proportional, okay, and the angle in between them, would be congruent with the same angle in the other figure. So if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. Side angle side similarity. Looking at example 5, okay, we have this side 8 and this side 20. So 8 should match with 6 and 20 with 15. The angles in between them are congruent. So if the sides are proportional, does 8 over 6 equal 20 over 15? Let's see, and they both reduce to 4 over 3. Okay, so yes. Okay, those two sides are proportional, and the angle in between them are congruent. So this is yes, side angle side similarity. So the statement, and we could say triangle, let's go KJL, would be similar to triangle. If I went KJL, I'd have to go NMP. All right, let's see, example 6. So let's say triangle ABC and ADE. So the whole side of triangle AB, or side AB, is 25. Does 25 over that same side in the other triangle, which would be AD, was 15, okay, is that similar to, let's see, 21 over 12? Are those proportional? Because the angle right here is in both triangles. So angle A is in both triangles. So we do have an angle. We have side, an angle, and a side. Now, it is side, angle, side if those two fractions are the same. The ratios are the same. Side AB to AD, side AC to AE. So reduce those. 25 over 15, is that the same as 21 over 12? Divide that by 5, that would be 5 over 3. And let's see, 21 over 12. Those divide both by 3, that's 7 over 4. Those are not the same thing. So they are not similar. Okay. On your assignment, and so for the assignment, same idea, okay? Determine whether triangles are similar. So it's a yes or no, and if they are, you write down which rule applies, okay? And then also write a similarity statement. Okay, so you do question 1. Let's see, are they similar? Well, let's see. That angle right there, this looks like a possible side angle side similarity. Okay, so 3, the smaller of the two, would have to match up with 9, the smaller of those two. So does 3 over 9 match up with 5 over 15? Is that the same? That's 1/3 and that is 1/3. That does equal 1/3. So check with this, with the ratios of the sides, and then the angle in between them, angle F and angle T, are the same. So that checks the other box of similarity. So this would be yes. Determine whether the triangles are similar. Yes. If similar, how? So this is side angle side similarity. Okay, now let's write a similarity statement. Triangle. If you start from the small one, great. Or you can start from the big one, it doesn't matter. It's not specifying which way we have to go, but I'm going to say, all right, GEF similar to triangle. If I went GEF, then that would have to be SRT, I think, how that would have to go. SRT. Okay. And or you could write it like that and say those triangles similar, and the reason, if you're doing a proof, would be side angle side similarity. All right. There you go.